Hello everyone, thanks for joining our webinar today. If you have any questions during the session, please submit them via the Q&A button at the top of the interface. Those questions will be answered at the end. This webinar will be recorded and you will receive a copy of it delivered to your email account. I hope you enjoy, and I'll now hand you over to our experts, Sami Guiziani, Product Marketing Manager at ST Microelectronics, and Johan Lopez, who's the Senior Pre-Sales Engineer at Cube Company. Over to you guys.
Thank you. Hello, everyone. My name is Sami Guiziani. I'm product marketer in ST Microelectronics, working for graphics on STM32. We'll start with a quick introduction of STM32 products around the graphics, and then I will hand it over to Johan for cute presentation and demos. So let's start. What we are doing at ST with STM32 products is trying to accelerate what we call the HMI of things. And so all the embedded products are getting smarter with more advanced features, requiring more advanced user interface so that users can profit from all these new capabilities. And so this is what we are trying to enable with STM32 product, adding smartphone-like user interfaces in embedded devices with using cost-effective microcontrollers. To achieve this, we embed in our products 3 different types of acceleration or hardware graphic IPs. The first one is our ChromArt, which is a 2D graphic accelerator, allowing to accelerate 2D image copies, transparency effects, pixel format conversion, but also enabling efficient font management. And thanks to the ChromArt, you are able to have fluid motion transparency effects with 80% less CPU resources that you can still use for your main application or to develop even more advanced graphic features. Another IP is the Chrome GRC, which is a memory optimization IP, allowing you to save up to 20% of the needed SRAM when dealing with around display. And so you are only storing in RAM the useful pixel data you need. The third IP we are embedding in our products is a hardware JPEG accelerator, allowing you to add to your graphic interfaces motion JPEG videos. So for startup branding videos, but also to add some tutorials to your graphical user interface. In addition to this graphic acceleration or memory optimization, we are supporting a wide range of display interfaces. And so classical parallel interfaces, but also TFT controllers and MIPI-DSI controllers. So MIPI-DSI are displays coming from the mobile phone industry with high pixel density and very low pin count. Today, all these IPs are embedded in a wide, really large portfolio, more than 200 advanced graphic part numbers in the STM32 portfolio. So they are spread in different families with resolution support up to XGA. And these products are available in different package flavors so that you can find what is suitable for your application. What is new in our portfolio is the introduction of F7 and H7 value lines that are in production today. These products are coming with small flash and so cost-effective products. The idea behind it that you will, for graphic cases, you will always need some external flash to store your bitmaps. And so this is a way to have a cost down. And then a new H7A product that is now is coming with more embedded SRAM, allowing you to handle up to half VGA, 16-bit per pixel resolution without any external RAM, and in packages as small as 64-pin QFP. So very cost-effective graphic support. Of course, these products are embedding our accelerations, ChromArt, JPEG, and TFT controller. If you may need more information about our products, you can visit st.com/stm32 GUI and you will find all needed information. I hand it over now to Johan for more details about Qt and how Qt is taking advantage of STM32 products.
Thank you, Sammy. And hello, everyone. I will start sharing my screen. So I will today present you, or I'll give you a step-by-step guide on how to basically start using Qt for MCU. So covering the installation to the configuration of the environment, the development of a small project, and finally the debugging. But before I start with this live demo, I would like just to make a short introduction on Qt in case there's anyone in the webinar who doesn't know much about what Qt is. So Qt really is a native cross-platform application development toolkit. Native because it's mainly based on C++, so it always produces native code. It is cross-platform. I will come back on that just on the next slide on which platform we support. So it means that you can only just write your code once and then recompile it to deploy to different target platforms. And it really contains, it's mainly a framework, a development framework. So it contains APIs to develop different parts of your application. It's mainly known for GUI, but it also contains many other APIs for things like database access or network or map and so on. And besides the APIs, it also contains a full integrated development environment. It's called Qt Creator. That's what I will be also using today to show you the demo, as well as design tools called Design Studio and 3D Studio to bridge the gap between developers and designers. As I said just earlier, just before, Qt is cross-platform. So this is a list of the platforms that Qt can run on. It's embedded with embedded Linux, Windows embedded, or a selection of the most common RTOS like QNX, VxWorks, and Integrity. It's also for desktop, the main platforms, Windows, Linux, and Mac OS. Mobile with Android and iOS. And also since recently, as a matter of fact, the latest version, you can also compile a Qt application to run inside a web browser using the Qt for WebAssembly technology. But what we're going to talk about today is something more specific. It's Qt for MCU, and this is our latest effort to extend the use cases of Qt on embedded. Because until now, Qt was mainly used on the higher-end types of systems, embedded systems. And thanks to this new feature in Qt, you can now also target lower-end kind of devices. And how that works? Well, it really lets you as a developer use the main GUI technology in Qt, which is Qt Quick, also known as QML, and use it on top of a Cortex M. And the difference between this solution and regular Qt on Linux, for example, is really what's in between. It's the actual Qt library. So on MCU, Qt doesn't actually use the same libraries. It's based on a new runtime that we call Qt Quick Ultralight. And this new runtime has been really optimized for size. So it's really much smaller than the regular Qt libraries, and also for performance on this kind of system. So it does make use of hardware acceleration like the ChromeArt acceleration on STM boards. And what that means is we developed this from scratch is also it doesn't require an operating system. So while the regular Qt libraries need any of the operating system I showed just in the previous slide, Qt Quick Ultralight can run on bare metal. So let's start with the actual demonstration and the small project creation. Today, I will be using an ST board. More specifically, I will be using the STM32 F769i, so the discovery board. But the evaluation package also supports another SD board, which is the STM32 F7508. And quickly before we start, just below you can see a list of software you must use in order to complete this kind of tutorial or guide. First of all, you need to be running on or using Microsoft Windows, the evaluation package as tools only for this platform. But of course, later we will release, the final release will include also packages for Linux. You will of course need the Qt for MCU evaluation package, which I will just show you in a few minutes how you can get that if you haven't got it already. And after that, I won't detail them, but this is the full list of what you will install. You need to install so Qt Creator for development, CMake for building the project, Clang, this is actually included with Qt Creator, Python, and then as well all the tools to actually build the application. So I will now start with the installation. So as I said, if you haven't got the Qt for MCU evaluation package, you can get it from the Qt account on our website. And it requires that you have an active Qt for device creation license. If you don't, then you can request an evaluation license from our main page. And then from there, you will be, after you actually got the license created, you will be able to download the package. If you add a regular non-evaluation license, the access to the evaluation of this product is automatically granted for you. So just head to the download section in your Qt account, and then in the product list here, you can see the Qt for device creation MCU evaluation. Just select that, click here and download. You will get the zip file containing well, a bunch of stuff, and you can install it anywhere you'd like. It doesn't really matter. I will actually show you now what it contains. I personally installed it here, and well, it really just contains the tools to be able to compile a Qt application or MCU, all the CMake configuration files. It has also pre-built binary images of one of our demos. This is actually what you can see here now. I have a live camera feed showing one of the boards I have, which is again the STM F769, running the demos with chips. So this one, you can directly flash it and just play with it. You can see that it runs smoothly at 60 frames per second. Hopefully, I'm not sure you can actually see that in the video, but it actually is. And it contains as well the source code of this example here, plus a couple of other ones. And of course, the header files and the library in binary format. We do not include the source code of this. So yeah, let's start then with what you need to do in order to get Qt working correctly configured with this. So there are some steps to do in Qt Creator in order to get everything working. But just before I show you this, there's a preliminary step to do, and that is to set 2 environment variables so that everything works correctly. So just open the environment variable window inside Windows, and just edit the path environment variable, and make sure you add these 2 lines here. So add the bin directory from the Qt Creator installation, and as well the bin directory of Clang inside Qt Creator. And if you set that, you won't run into some strange errors. Then once you have done that, you can actually start Qt Creator, which is running now here. And there's one thing you need to do is to enable a plugin which is not enabled by default. So for this, you need to go into the Help menu here, and then inside the About Plugins entry, where you will see the complete list of all the plugins installed with Creator. And the one we want to enable is called bare metal. So just type inside the field here at the top, just type bare, and you will see this line. Just check the box here to enable the plugin. Then close the window, and you will actually have to restart Creator so that it takes the change into it. So I just closed it. Let's restart it again. Then, once this is done, there are 3 steps to configure inside Creator before you can even start creating a project. This is simply because at this point, this is an evaluation package. Eventually, we will have all of this fully integrated inside Git Creator, and it will be really much more seamless, where you will just create a project, click run, and that's all you really have to do. But as I said, for now, there are a few manual steps to go through. So the next one is to create a kit. A kit inside Git Creator is really just a configuration of a tool chain, a debugger, a Qt version, and so on, to combine together to produce a binary for a given target. And this is what we need to manually create. For this, we go inside the tools menu here, and then inside the options. And here at the top left, you can see the kits section. This is what we need. But before we even create a kit, there are a few things we need to create before that. The first one is to register the debugger that we will need to use with our board. So the debugger is actually provided by the ARM embedded toolchain, and we just need to add it inside Git Creator. So head for the debugger tab here inside the kit section, and then click the add button. Just give the name to your debugger. It doesn't really matter. It's just for you. So let's call it here ARM GDB. And then on the field below, we can set the path to the location of GDB. In my case, I've installed it at the root of the C drive in this directory. Go inside the bin directory, and then you will find this executable here. So make sure you select the GDB-py and not the regular GDB, otherwise it won't work. Then just click apply. And then we need to configure how GDB will be initialized. So for this, we need to go inside the device section here, and then on the bare metal tab, and then on the add default profile, we will just give it a name. Let's call it ST-Link GDB. You can leave the default option here. We're only going to change the port, and I will set 61234. And there's one init command to set, and that is just load, and one reset command, that is mon reset. Once you're done with that, just click apply. And there's one last step before we actually create the kit, which is to create the device we will deploy to. So go here in the device tab, click add, select the bare metal device type, and then start wizard. You can also give it a name. I will just call it the name of the board I have, which is the STM32F769R. And here it's important in the list below, just make sure you select the profile we just created for GDB, and then click finish. Click apply. And now we can actually create the kit. So go back inside the kit section on the kit tab, and then let's add here manually a kit. Let's call it STM32F769I. We need to choose the device type and set it to bare metal device here. And the actual device is already set by default. It's the one we just created. Just leave that on. The following fields can just be left empty. They are not needed. And for the compiler, you can actually also leave it to no compiler, because it will be actually CMake that will detect the compiler and set everything correctly. So just leave this also with the default empty values. Then there are 3 environment variables that we need to set. You see here on the next line, environment, just click on the change button. It's empty by default. And then I will just copy paste these, but I'm going to explain you what it does. Of course, you will need to adapt the paths here to the locations on your machine. But the first line is the ARM GCC _ directory, or dir, and you should set here the location where you install the ARM toolchain. Then the second one is the location where you have extracted the Qt4 MCU package. And finally, the last environment variable is the location where you have installed the STM F7 SDK. So make sure you set all this correctly, and then hit the OK button. The next thing to set is the debugger. Same here, we need to select what we have created earlier, so the ARM GDB debugger. The Qt version can be left to none at this point. It doesn't matter. And for the CMake tool, also in case you might have multiple ones, if you already have some previous Qt installation, make sure you select the system CMake. And finally, the last configuration to set is the last line here, the CMake configuration. Click the change button. Remove everything you have in there. If you don't, it will actually not work. So make sure you remove everything. And there's one variable to set, which is this one. I just pasted. It's the CMake toolchain file variable that you need to set to one CMake file, which is actually located inside the Qt Ultralight directory. So just set that to your Qt4 MCU installation, and just set the file here to the correct one depending on your board. I will be using here the STM F7, so I set it to this one, but if it was another board, you would need to look into this directory and set the correct file. Then click OK, and now we're all set up for actually building our first Qt application. So let's just do that. Let's close this window by clicking OK. And let's create a new project. So you can do this here, or you can click on the File menu here, a new file or project. And as I said earlier, this is still not fully integrated. The Qt4 MCU is not fully integrated inside Qt Creator. So the actual way to create a project for right now is to go into the non-Qt project, which is not correctly named at this point, but anyway, and then click or select the plain C++ application. Choose that, just give it a name. So I will call it Qt MCU, and just define a location for your project. Click Next, and this is important here. Make sure you change the build system from QMake to CMake, as a Qt Ultralight can only be, or a Qt Ultralight project can only be built using CMake. Click Next, and the last step is to select the kit we will be using to build our project. And of course, we want to select the kit we just created, that is the STM32 F769. Let's check that box and then click Next. The next page really, it doesn't matter. You can just leave things by default and click Finish. And Qt Creator has created a default main.cpp file, as well as a default CMake list.txt. And that is really the project definition for CMake. So we won't actually be needing the main.cpp. So I can just go ahead and delete that by going where my project is and remove that file. The reason is that the Qt application for MCU doesn't actually use CPP as the main entry point. You will be using QML for that, so that's why I'm just removing that file. And then I need to make a few changes to the project file. First of all, I will change the minimum CMake version to 3.13. This is the minimum version actually required by Qt for MCU. This one you can just leave it there. These two here are not necessary. I will just remove them. And I will also remove the main.cpp file from the target because it's not there anymore. All right, so inside the project file, there are a couple of lines to add, and these are related to telling the project to build against the Qt for MCU libraries. So for that, we first need to tell CMake to find the correct packages that we need. And for this, you can use the CMake command called or named find package, find underscore package. And as argument, you give the package name you want to use. In this case, it's called Q uppercase, UL lowercase. So make sure you add this line to correctly add all the Qt libraries to the project. And also we need to add a line to tell which library the executable should be linked against. For this, we use the target underscore link underscore libraries. We give it as first argument the name of the project, which is Qt MCU. And as a second argument, we pass the name of the library. The library is named this way, QUL, sorry, and then ultralight. And so these are related to two lines that you need to add to be able to compile a Qt for MCU application. So let's add our first source code file to the project. And as I said, the main entry point must be QML. QML, for anyone here in the webinar who doesn't know this, is our own language, so the Qt specific language to define graphical user interfaces. It is very easy to learn, very quick also to write, and it looks really similar to JSON and JavaScript, but we will see that in a bit. So let's create a new file for the project here. And I'm going inside the Qt menu here, and then select the QML file and select choose. Let's call that file main.qml inside our project directory. And this can be left with the default values. And let's just click finish. I have my main.qml file created here, opening the editor. But since, again, I'm repeating, the full integration is not done, it didn't actually add it to the project. So we need to go inside the CMake list.txt, and we need to add the QML file to the target. So for this, it's actually a Qt specific command, which is QUL underscore add underscore QML. This is how you add a QML file to the project. And you pass the name of the project, Qt MCU in this case, and then the list of all your QML files you must add. In this case, I have only one, and that is the main.qml. I'm going to go back inside the QML source file, and before doing anything fancy, I will just like that, just compile it and flash it on the board so to check that everything actually works. So I will actually just replace the root item of my user interface to be a rectangle instead, so that we actually see something. So by default, the rectangle is white. And I actually almost forgot something, and this is for anyone here who already knows QML. There's one difference when coding a UI for MCU is that you must tell Qt what is your main QML file. And you can do that by just adding a line of code inside the relevant QML file, and that is pragma main. So make sure you add this inside your main QML file. This is how Qt knows it should be the main QML file to load at startup. Another comment as well for people who already know QML, the import statement with Qt for MCU is optional. So if you want to, you can completely remove it. It will still work. It's just that you will lose the syntax highlighting inside Qt Creator. So I actually recommend to leave it just for the sake of having the auto-completion here and the syntax highlighting. So let's just go ahead and compile the application. Run CMake first. Oops, sorry. I will actually change to a release build instead. Hit compile. I'm having actually, this is actually a bug. If you see the same thing, just exit or quit Qt Creator and restart it. This actually happens after setting the project the first time, I've noticed. So just restart Qt Creator, reopen your last session, and now it should work. So let's just hit build. It's now compiling. And just to explain a bit how it works, you see that here on this line that says running QML to CPP on main.qml. So what's actually happening under the hood is that the MCU is not actually going to interpret the QML. During compilation, there's a tool that converts all the QML files to C++. And this is one way how it can achieve really optimal performance. And when it's done, it generated a binary file which can be flashed onto the board. And I will show you now two different ways you can flash this program to the board. The first one is by using ST's tool, the STM32 ST-Link utility. This is how also you can, for example, flash one of the demo binaries we include with the evaluation package. And it's fairly straightforward. But before you actually flash the file, you must click on this menu here, the external loader, and make sure, so it's already configured here, but you need to go into the add external loader and select the correct board that you're using here. Make sure it's checked, and then click validate. And once that's done, you can click the target menu, click connect. It will actually connect to the board. And then you can open the file to flash by clicking this button here, the program and verify. And by clicking the browse button here, just go inside the directory where you built your app, your Qt app, inside the build directory, and then release, and then you have this hex file. So just select that, open it, and just click start. And you should see the live video feed here, and you just see that it just flashed. And now we have a white rectangle as expected. So nothing really sexy at this point, but we're going to do something better now. But there's actually another way to flash, probably easier way, or at least more seamless when using Qt Creator. Let's just disconnect this tool. And if we go back inside Qt Creator, there's a way to tell basically Qt Creator to flash the executable right after building it. So for this, we can go inside the project tab here, and then inside the build entry on the left here, We'll hide this for now. And we're going to add a new build configuration. Actually, I'm not going to add a new one. I will just clone this one. So just select release, click the clone button, and I will call it flash release. Click OK. And the only thing you need to change is in this section here. Go into the build steps, click on details, and we're actually just going to tell Qt Creator to use a different build target. And that is, rather than being the one called all, it's the one called flash underscore name of your project. So make sure you select that for your flash target. And that's it really. So now if I select here in the target selector, the release target, it will just build. But if I select the flash release that I just created, and let's just try that, it will compile. And then, as you can see here now, also flash it. So yeah, from this point, and I really recommend it to do it this way, you can just develop, click the build button here, and it will always flash directly to the target. So let's continue with our project. Let's add a bit more advanced, let's say UI elements to our, for now, empty screen. So I'm back inside my main.qml file. By the way, maybe I can make this a bit bigger so that you can see and read better, more easily. So, well, QML really, as I said, looks like that. It's just a hierarchy of objects that you just write. And each object has properties that you can just set like that. So for example, rectangle has a color property. So I just set it this way, and in this case I will set an X color code, which will be still white, but a more fancy kind of white as what we had before. So with a tint. And then you could set other properties on the rectangle, more like probably what you would typically set is a size, for example, a width and a height. But in this case, it's a special item, it's the root item. So since it's a root item, it will always fill the screen. So you don't actually need to set it. You can set it if you want to, but it's not mandatory. So I will not set any size here. If it was another rectangle, not the root one, of course, you would, in that case, need to set a size. And then just to, again, show you the basics, I will add a text inside my screen, and I will center it. And for that, you can use the concept of anchors. It's very easy. You just tell that I want to center my text inside the screen with this line. So I just do it this way. I just say that the text should be centered inside the parent. And then I set the text property, which actually contains the string, where I will just set it to hello world. And so that it's a bit more readable, I will also change the font size to 30. And now I will show you the video feed again. And if I click the build button, it will build it, flash it straight away, and you should be able to see our text on the screen. Here we are. So again, this is really the basics. We're going to go a bit deeper inside what you can do. But I would like just to make a comment first about the text, and this is for people who already know about QML. When using Qt for MCU, you get access to a new API, which is called the static text. So instead, you can do that. And it's an optimized version of the text item, which is lighter and faster to load. So if you know that your text, like this one here, is just like a title, you know that it's never going to change. It's not depending on some variable. So instead of using the regular text item, make sure you use the static text instead. And otherwise, it's exactly the same thing in terms of API. All right, so let's just now move on to the next step and do something a bit more advanced. So I want to add an image now, because of course most UIs are made up of different images. So this is one of really the most basic type of items you would put inside a UI. For this, you have the image type, fairly straightforward. And you can set it to load an image. But before I do that, there's one thing. That's how do these two items get laid out together. So of course, if I just do that, they won't. They will just be kind of on top of each other. So for that, you can use layouting classes or types in QML. You have different ones, but one of them is column and row. So in this case, I just want the image to be below, just below or under the text. So for that, I can use the column type. So I just wrap my text and my image inside the column. And now, since my static text position is defined by the column, I can just remove this because it's not necessary anymore. And instead, I actually set it on the column. So my column should be centered in the screen, and then it will contain text and an image. There's just another thing I can add so that it looks a bit better. I will center the horizontal position of my text to the parent horizontal center, so that everything is aligned horizontally. And I will do the same on the image. And again, image has different properties. You can, by the way, in Qt Creator, always access the documentation by putting your cursor on a type name and then clicking F1. And then you will see the different properties you can set. Keep in mind that not all of these properties are accessible with Qt for MCU. You can see exactly what is and what is not by looking at the Qt for MCU documentation. But in this case, really there's only one thing we need to set. It's the source property that defines where to find the image. And I will actually add an image inside my project. Let's just open the project location here. And then I actually have it here. Let's just copy paste this directory inside my project. And it contains just the Qt logo in PNG format. So to add this image to my application, all I need to do is just to actually define it here, and then Qt will take care of the rest. So just, you can use relative paths. So just set it this way. And when you build it, now that's what I'm actually going to do. It's going to do, let's say, some steps automatically for you. It will, first of all, it's going to optimize it so that it's not actually in PNG format, because PNG would take some time to load and so on. So it's going to convert it inside an optimized format for the given board and include it inside the binary. And really, that's all you need to do. I actually forgot to do something here, but anyway, you got, you can see now here on the video that our logo has been added where we wanted it, but it's just, I will add here a spacing inside the column so they're a bit more spaced. And let's do it this way. Let's just rebuild. It's flashing now. And yeah, it looks a bit better. All right, so this is how these are really, I would say, these three elements: the rectangle, the text, and the image are the most, the most basic types of items you have in QML. Thankfully, that's not all you have access to in QML. Otherwise, you would be fairly limited to what you can do. Qt also comes with a set of controls. That's what we call them, controls, or Qt quick controls, that provide you with more advanced widgets or UI elements, like, for example, buttons, sliders, checkboxes, and so on. So this is what we are going to use now. And for this, we can import the module. Again, this is fully, completely optional, but I will do it just to get the syntax highlighting. So let's just add the quick control module here in our QML file. And there is as well something to do inside the project file here in the cmeclist.txt. And we need to add a new library to link against because it's just modularized and it's in a separate library. And the name of the library is, I will just paste it. It's like this. It's a bit a long name, but I actually can explain you one thing about this. Is that if you want, when you're using any of these controls, like let's say the button, you have two choices. Either the button will have a default look and feel, which like a theme if you want. So we include one theme at the moment, but you can also fully customize it. And depending on which version you want to use, if you want to use the customizable version or the default theme version, you need to link against a different library here. So when using the default theme, this is what you need to use. If you want to use the customizable version, just remove the style default, and this is what you need to use. And then, yeah, just look at the documentation how you can actually customize the control. So once this is done, we can actually start using the types. I'm back in my main.qml, and now I will add a switch button to my user interface between the text and the image. And what I want to do is the kind of UI logic I want to implement is I want my Qt logo to be visible whenever my switch button is on. If it's off, the image should be invisible. And now it will illustrate one of the probably most important features of QML, which is called bindings. And we'll see if you don't know QML, this is really powerful and easy to use. So let's just give a name to our switch so that we can refer to it somewhere else inside the code. I will call it switch. So for that, you need to use the ID property. And then I will call it switch button. And to be able to tell that my image should be invisible when it's off or visible when it's on, I can just assign something to the opacity, for example, property. And I just need to write one line. It's switch button, sorry, checked. So the switch button has a checked property, which is true whenever the button is checked, otherwise it's false. And I just set the conditional statement here. And if it's checked, then the opacity should be 1. Otherwise, it should be 0. And just with this line of code, whenever this will change, the property will be automatically reevaluated and reassigned. So now I can just compile. We're having again the same bug as earlier, so I will just restart Qt Creator. Let's compile. And in a few seconds, the new updated version will appear on the board screen. So you see now that we have our switch button, which is actually here. And if I click it, then the Qt logo is displayed. If I disable it again, Qt logo disappears. So this is typically how you implement, let's say, UI logic with QML, just by writing these kind of bindings, which is really much more, say, efficient and quick to do rather than writing lots of lines of code to do the exact same thing in C++. And well, what now if I want to add some animation? Because this is also one of the main features of QML is the ability to define easily and quickly all sorts of animation. So let's say now that rather than just showing the Qt logo from fully transparent to fully opaque, I want to smoothly transition, like it's kind of fade in, you know, and fade out. So for this, I can add an animation on the opacity. And you just can use a language feature, which is called behaviors. So you can install a behavior on any property by doing this. So you just type behavior on and then the name of the property you want to animate. And in this case, it's the opacity. And inside the brackets, you just add an animation. In this case, opacity is a number, so you need to add a number animation. And well, probably the main property to set on the animation is the duration. So it's in milliseconds. Let's set it to 600 milliseconds. And so just with this line of code, we have told Qt that whenever the opacity changes, it should not happen at once. It should happen over 600 milliseconds and transition smoothly. Another parameter you can set on the animation is the easing type. So by default, it's going to be a linear transition, but if you want something else, just look at the documentation. There's a bunch of other options you have, and you can set the easing type. And to make something a bit more fancy, I will use the out cubic easing type, which just looks, which is not linear really, and it just looks a bit different. But let's not stop there. I actually want to do something even a bit more advanced. I want my Qt logo to appear from the bottom of the screen rather than just fading in. I want to fade in, but also appear from the bottom. So for this, I want to animate the position of my image. Except that since my image right now is inside a layout or column, I'm not supposed to directly change myself the position. So to be able to do this animation, I will need to wrap the image inside another item. Item itself is empty. It's more like it's more or less a placeholder that doesn't have an appearance of its own. And I will just set it to be the same size as the image, again using bindings. So I set an ID on the image. I will call it Qt logo. And I can bind the width and the height of the Qt logo to this item. So I just do width is equal to the Qt logo width, and the height is equal to the Qt logo height. And this will automatically be adjusted whenever this changes. And I will actually also center everything. Let me hide this for now. And I will center everything, including the switch and this item. And I can remove now this line here. So now that I kind of wrapped my image inside another item, I can freely move this image without being affected by the column. So I will basically use the same logic as what I've used here. But now instead of changing the opacity, I want to change the Y position. And well, I can even just copy paste this one here. It's the same logic. But now, whenever my switch button is checked, I want the position to be 0. So it will be just where the parent item is. And if it's not visible, or let's say if the switch is not on, then I want the Y position to be 50, for example. So that means that when it's invisible, it will be below. And whenever I enable it, it will appear from the bottom. But I actually need to add one more line. It's the same as this one here. Let's just duplicate that line. And I will also apply the same animation on the Y property. So let's just go ahead and click the compile button and let's have a look on the results on the board. Okay, we have our switch button. So now click. We do have the Qt logo appearing from the bottom, as well as fading in and fading out when it disappears. So this is what we wanted. Again, well, you might not really see that on the video because I don't think the frame rate is very high, but it's actually very smooth, 60 FPS. All right, so we're done with animations. You, I think, understand the main concepts here and how it works. There are other ways to do it, but then I will let you read the documentation for this. The next step is, well, how do you add any logic to this? I mean, actual business logic, because for now, all we have done is just UI. It's empty UI, so it doesn't really do anything. So typically, if this was a product or an actual device, you would most likely want to control the hardware. I don't know, turn on some lights, do something, I don't know, access the network, send some data, and so on. So when using Qt, all the logic is written in C++. But then you might ask, how do you combine the C++ with the QML? So this is what I will show you now. It's very easy. It's actually even easier than a regular QML when you're using Qt on for example, Linux or Windows. We just need to create a special interface, which is very similar to QObject. For the people who know Qt. But since QObject has a very big overhead, especially in terms of memory consumption, we didn't keep the full functionality of QObject. And instead, we replaced it with something much lighter, but that provides at least some of the features like signals, properties, and slots. So in order to demonstrate this capability, I will add to my project some C++ files that I have created earlier, which is what I have on my desktop here, where I have a LED.h and a CPP file. So basically what this is in this case would be the business logic, or actually more correctly here, it's the hardware access. It just contains a couple of functions to turn on a LED on the board on and off. So now I want to control it from the QML, so that whenever my switch is on, the LED should be on as well, and when it's off, the LED should be off. So now that I copied my files inside the project directory, I need to add them to the project. So for this, I of course need to compile them. So I use the standard cmake command to add a source file to the project. I just pass the name of the project. And I add my two files. So the first one was led.h and then led_STM32, blah blah .cpp. All right. So now I have my files inside my project. Actually can show you what it looks like. Again, it's very simple. Just a C API with two functions. The first one is green LED switch on. The second one is green LED switch off. And the name is pretty self-explanatory on what it does. And by the way, this actually what it does is really just using the ST hardware abstraction layer to set or reset a pin that is connected to the LED. So, well, let's now see how we can call this from QML. So as I said, you need to create a special interface. So we need to create a C++ header file. So just create a new file, C++ here, and then a C++ header. Let's call it led_wrapper.h. Let's finish. And well, all I need to do is to create, as I said, an interface. So for that, we need to include a file or header file, which is ql/. In this case, I'm going to use this one, the singleton.h. You could also have used the Qt object, but in this case, there's only one function I need to expose. So I do not need to instantiate any object inside QML. I just need to access one function. So for that, the singleton type is a good option. So let's just create our interface, which I will call LED, and it needs to subclass the singleton type, which is all right. So now we have our basic class declaration, and from now on, anything that I add here, any public function, will be automatically accessible from QML. So if I add a set enabled function that takes one argument, well, this function will be accessible from QML. I will show you just after how you actually use it. So let's include our C functions inside our header, and let's just, well, very simple implementation. If our argument is true, then we call the green LED switch on. Otherwise, let's just call the other function to switch off the LED. And that's it. So we have our class or interface definition now. The only thing to do is, again, something inside the project file. We need to tell Qt that this header should actually be converted to QML, or it should be accessible from QML. So of this, we go inside the CMake list.txt, and we need to add one function call, which is QUL underscore register underscore types. So this is any header file that must be accessible from QML should be processed through these functions. So just pass the MCU project name and then the name of the header file. And finally, there are two variables to set. This is important. I will just put it here. You need to add to the include path both the source file, the source directory here, as well as the build directory. So if you don't do that, it will actually fail to compile. So make sure you add these two directories to the include path. And yeah, once that's done, let's just check that it actually compiles. I did make a mistake, which is all right, there's some error. I'm not sure. Whoops, actually, I should not have added a comma here. That was the problem. And then it should actually compile. And well, it's going to compile, but at this point, since we didn't do anything inside the QML, it's not doing anything yet. So let's go inside the QML, and now I have access to a QML type called LED, just the same as the C++ class name I've declared. So what I want to do is to react to a signal on the switch, and that is on check changed. So whenever the checked property changes, I want to do something. In this case, I want to call the set enabled function on my LED class interface, and I want it to set it to checked. So really, essentially, what I did here is that whenever the switch changes its state, I enable or disable the LED based on that change. Well, let's try it. Let's compile it. And flash. And now you can see that here at the bottom left, you see you have a green LED and it turns on and off as I switch the button. So this is how you would typically access some logic in C++ from QML. As you can see, it is fairly straightforward. So the last step before we take any question, if there is any, is how do you debug? So you can do that from Qt Creator. There's just, let's change to debug mode here, but there's only one thing you need to do before being able to click the debug button here. You need to start a STGDB server. So for that, you just open a console from a terminal from Windows, and you need to go inside this directory that you see here. It's actually a directory inside the STM cube ID location. And then you can simply, I'm not going to explain it now, you can find this. We will share, by the way, I will share all the materials that I'm using now so that you can repeat this more easily yourself. So yeah, I just pasted a command here to start the GDB server. As you can see now, it's waiting for connection. So we can go back to Qt Creator. And now if I click on debug, it will start a debugger on the remote target. And actually it will also flash. So if you do any changes to your QML and click debug, it will actually flash the new version as well. And as you can see now, it's starting. I didn't actually set a breaking point. So let's do that, for example, in our LED wrapper, and whenever, for example, we enable. Okay, I might have needed to, seems to be some issue now, but anyway, I'm not gonna go and fix the problem now. The point of showing you this was that to be able to use the debugger, you need first to start the ST-Link GDB server. All right, I think we have covered all the necessary steps for you to get started with Qt for MCU. Hopefully this was useful. So now we will take some questions, if any.
Yeah, thank you. I think there's some questions that have come through. So just to recap, if you can use the Q&A button for your questions.
Right. So the first question is, can ultralight run along a RTOS? So that's a good question. At this point, it isn't. So the initial version, and especially the evaluation version, can only run on bare metal. But of course, we are currently researching and developing ways to use Qt Ultralight on operating system. For example, of course, FreeRTOS has been requested a lot, but even maybe also Linux, it might make sense in some cases as well. So yes, there will be OS support in the future, but for now, only bare metal. Then let's see. There's a question about the final version to know if it will actually start the GDB server automatically or not, or if you will still need to do that manually. I think, as I said in the beginning, eventually we want to give you the most seamless experience as possible. So yes, in the end, all of this will be done automatically. It will be the same experience as developing an application for desktop, for example. You just create your project, click build, run, and that's it. And same for debugging. Then we have a question about screens, and if it's how to know if it's compatible with Qt. Well, I would say that it's not directly related to Qt. It's more related to the board itself. Of course, you will need some drivers, but basically, when using Qt Ultralight on a given board, which we do not support out of the box, meaning also on another screen, of course, there will be some adaptation to do inside Qt Ultralight to make use of this new screen. But, well, normally there should not be any problem. Of course, there will be some work to do, but as long as it supports, I mean, multiple pixel formats and so on. I mean, I think it's a case-by-case thing, but I don't see a reason why it should not be compatible with Qt itself. It's more a problem of hardware compatibility, I believe.
I may add just some.
Sami, can you add?
Yes, sure. So definitely it's a matter of it's a matter of BSP actually. So when you use any display, it can be simple SPI or parallel or whatever. Yeah, all what is needed is to have the right BSP prepared for it. So we're using the right drivers and and then connect it to the HTML file. And then what Qt will do is just interaction with these BSP to send images and to draw actually forms on the screen itself. So it's much more board setup and BSP setup.
Yep. All right. Thanks for the precision, Sami. Then there was a question about the possibility to use the built-in form editor inside Qt Creator to build the UIs rather than writing code. So for now, it's not really possible because there are types inside Qt Ultralight that do not exist in regular QML. So most likely you will end up in situations where it will just not work. But eventually, again, this is of course something we want to support. So this will come in a future release to fully support the what you see is what you get editor inside Qt Creator.
Well, I think we've got time for 2 more questions. I think there's a few in there.
Yes. So there's a question about the documentation, or if there is any documentation on how to port Qt Ultralight to different MCU. So at this point, there isn't. We actually do not, well, we only release the source code of Qt Ultralight to commercial customers. And typically, at least the approach for now is that if you need to use Qt Ultralight to a different board, you would have to work together with our professional service team to port the product to this hardware, basically. Then
probably examples can be also available.
Of course, eventually we might have all kinds of examples and documentation to do that, but at least initially and for now, we will need to help you to port it to a new hardware. And then last question is if there is a simulator to be used. This is actually, I think, in the chat, not in the Q&A. A simulator to use rather than actually using the board. So there is no such thing at this point. So actually what you can do is you can compile the application for desktop. It will be the same UI, the same code being run, but it's not actually an emulator or simulator. It's really just the code being run on Windows. But this is possible. And maybe one last one, because it's a short one to answer. There is a question about STM32 MCU being available or not as open source in open source version, and the answer is that it's not. It's at least at this point, a commercial only product.
Great. I think that's all the time we have for today, but thank you, Sami, thank you, Jan, for your time, for your presentation, and thanks everyone for joining. If you have any more questions that we didn't go over, please send us an email at info@q.io and we can answer them for you after the webinar. But thanks again for joining, and until next time. Goodbye.
Thank you.
Goodbye.
Goodbye, everyone.